Hi guys, it's me again, and today we will be doing the patriotic table of elements and pictures. Okay, so today I found this website and during homeschooling, and I said, "Can I make a video real quick?" And she said yes. So this is under www.chem4kids.com. Okay, so but what I have right here is the patriotic table of elements and pictures. So yeah, and I'm gonna have my assistant help me with this because this is my first time learning this. And then you have this side, which is the patriotic table. This is in words, pictures, words. Okay, I have my science workbook out, or my notebook. Fancy chair. Okay. So today we will be reading this, and I will be doing some links. Okay, so this is the patriotic table and the elements. We have H, L, I, and A, so you'll get the point. Okay, now we're going to getting to the heart and the soul of the way of the universe works. You know that a genetic atom, it's spelled ATAM. We will hit all these links later after we finish. Has some protons and neutrons in the nucleus and some of the electrons zipping through around in the orbitals. When those pieces start combining at specific numbers, you can build atoms with recognizable traits. If you have 8 protons, neutrons, and electrons, you will have an oxygen and nitrogen. N, which is atom. The atoms for each. Okay. If you wait, you will see an oxygen. The atoms for each element are unique, even though they are made of the same similar subatomic parts. And then we'll stop right here. And okay, so I'm gonna have my mom come out and help me with this because this is my first time learning about patriotic stuff. So she will periodic, whatever. Periodic. Okay, just don't judge me. Okay. Remember that the atom is the general term. If you can't see this. Okay. Remember that atom is the general term. Everything is made out of atoms. The term element is used to describe atoms with specific characteristics. There are billions of atoms, but you probably won't find more than 40 elements types of atoms in your body. Chemists have learned that over 95% of your body is made up of hydrogen, H, carbon, C, nitrogen, oxygen. Mom, I need help on a word. Sorry, Daddy. What's that P word right there?
Phosphorus.
Phosphorus and calcium. Everybody has calcium in milk, right? Mm-hmm. Okay, now explain this diagram.
Iron atoms on Earth and Mars are exactly the same. So Fe is iron.
That's okay, so you want me to draw it on my science thing?
You want to. Okay. But the ones that are on Earth and Mars look exactly the same. There's no difference.
I'm just going to put Earth. Okay, now you can read this and tell the list of elements.
Well, it says that there's a limited number of basic elements, which is like hydrogen, oxygen, iron. Those are basic elements. And then up to this point in time, we have discovered or created about 120. And then scientists just confirmed the creation of element 117 in 2014. So while there are more elements to discover, the basic elements remain the same. Iron atoms are found on Earth are identical to iron atoms found on meteorites. The iron atoms in the red soil of Mars are also the same. So it's pretty cool.
Okay, so Cu stands for copper, Fe stands for iron, Ti stands for titanium, Mg stands for magnetism.
Magnesium.
Yeah, that. And one more. Pb stands for lead.
Lead.
Oh my god.
Let's try.
I thought it was lead. It looks like lead. Wait. See? Lead. It's like the lead. Yeah. Okay. So we're gonna watch the video. Let me get to it. This is called the hydrogen video. Yeah.
And then finish the rest of the
Okay, guys, I'm gonna put it right here.
So you remember we had a very small balloon of hydrogen. Match on a stick to hydrogen. Big bang coming. Ready? Yep. Here we go. And the fact that we've come outside might actually give you an idea about what we're going to do, because we're going to make it a little bit bigger. So let's go for the balloon. Alright, cool.
Okay.
Hydrogen, I think, is very important because
Okay, the name is hydrogen. The atomic number is 1. The symbol is H for hydrogen. And if you find it on your elements, nitrogen should be around here somewhere. Mom, where is it? The hydrogen.
H should be. Number 1.
Wow, I'm so stupid right now. I'm not stupid. Okay, so it's right here on the top of the elements. Okay, now let's continue watching this. And this is the university, but I'm not going there. So
it's the simplest atom. The atom consists of a positively charged proton, which is relatively large, and a negatively charged electron that goes round it. Electric match. I think an electric match will go well on that. Oh, look at the tension on the balloon. I've really gone for a balloon. No, yeah. The tension. What happens is that hydrogen is reacting with oxygen, and H2 plus O2 reacts to form H2O and an oxygen atom. And then that oxygen atom goes on to react with another hydrogen molecule to make more water. And the reaction generates a lot of heat, and that heat heats up more gas to make it react faster. So you generate more and more heat, so the reaction that begins quite slowly with the first few molecules runs away, and that's why you get the explosion. So here we have a rather large balloon of hydrogen. Neil is just preparing our electric match, which we're going to attach to the side of this balloon. And some of the biggest explosions in the 20th century.
Okay, guys, so basically, they will not be taping it to the wall. They will be taping it to the grass.
Were in fact explosions caused by hydrogen and oxygen. So we filled up a balloon of hydrogen. And I think if you look at the hydrogen balloon, you'll see that it's slightly larger than those we've attempted before. Now we're going to try and detonate it or burn the hydrogen in the air by giving it a match. And the match we're going to use is again an electric match, which is connected to our detonator box. If you stick a pin in the balloon will burst because the rubber will the hydrogen will come out and it won't react with the oxygen because the hydrogen is cool. It's at the same temperature as the air. But the reaction of hydrogen and oxygen, like many reactions, involves the so-called activation energy. You have to put in a certain amount of energy to get it going. But once you get it going, you get more heat coming out than you put in to start it off. So, let's arm the circuit.
Here we go.
5, 4, 3, 2, 1.
Okay. I'm gonna pause it right there and go back to where we were. That's not it. Okay. It says now we will do the list of elements. Let me get this a little closer for you guys. Maybe that's enough. Okay. So it says, I don't know why that happened. Okay. Since the launch of this site, we've been asked why start with 18-inch? Why start with 18? The rules of the first 18 elements are very straightforward. First, the electrons fit nicely into 3 orbitals. Remember that the orbitals are the places you will generally find the electrons as they spin around the nucleus. 2, these 18 elements make up the most of the matter in the universe. 3, it's a lot easier to remember facts about 18 elements than over 100 elements. And then those are the elements: hydrogen, which is we're on right now, helium, carbon, nitrogen, oxygen, neon, sodium, argon. Okay. And then that's basic chemistry, guys. And then if you go up here, this is the example of the page. This is the example of the table. And see, this is what mine looks like. Oh, that's words. Yeah. So yeah, guys, just remember, if you want more videos on education, like this video and to smash that subscribe button. And I have a few more facts about hydrogen. So basically, let me write this down super quick, guys, and I'll be right back to you guys. Okay, guys, I am back. And what I got is hydrogen, H, should I say, because it's right here. And it's explosive gas, lightest element, 90% of atoms in the universe, sun and stars, water, or H2O, should I say, life's organic molecules. So yeah, that is the fact for today of science, and bye.